All right. Good morning, good afternoon, good evening, wherever you are in our virtual world. My name is Ron Dagdag, and welcome back from lunch. And today we're going to be talking about making neural networks portable, which is the title of what I have on our list. But I did put here leverage the power of machine learning with ONNX. Either way, we're going to be talking about ONNX. And let's get started. ONNX, we're going to talk about ONNX and not onyx, which is the mineral, ONIX, and not onyx in terms of like Pokemon. So Pokemon fans, I'm sorry I'm not going to be talking about Pokemon today. I will be talking about ONNX. All right. Let's go back and kind of review a little bit about programming. Programming typically where you have an input and you write an algorithm and do some calculations and would spit out answers. In machine learning world, we kind of flip that back where you have the input and you show it a bunch of answers. And what you're trying to do is to get the computer spit out an algorithm for you or create a machine learning model. So as a machine learning primer, typically you have programming on this side where we did talk about where you have algorithm input and answers, and then the machine learning on this side where you have answers input and it would spit out algorithm, and how they connect to each other is through this, right? So in machine learning world, we call your answers and input, it's called the training data. And then you would need a training framework in order to create a model. And then once that model is generated, you can actually replace it with that algorithm. And in machine learning world, it's called inferencing. And you would need a runtime in order to process that model with that input. And now it spits out the answer. And of course, it can be a feedback loop. Now you'll have more training data for your next iteration. Feel free to unmute if you have any questions, or if you place them in the chat or in Discord. We'll talk
Or if they just put
we'll
their
answer
hand
it later.
up,
Or yeah, you put your hand up, and we'll be able to connect if you have any questions related to this. Okay, and of course, let's move forward. So typically, when I was trying to learn about all these machine learning, the typical you'll have your machine learning training, and you would write it, let's say in Python, and you would use a library or framework called PyTorch, and you would run it locally in your machine, right? But if you're a web developer, you kind of know about all these different JavaScript frameworks. In machine learning world, I found out there's a lot more in terms of all these different frameworks you can use in order to train and generate your model. And then of course, there's different places nowadays where you can deploy your application. So it's not just you're doing it on the you're doing it on your machine, right? Not on your laptop or your notebook, but it could be on your phone, right? Or it could be in the cloud. Sometimes you deploy them through CPU or GPU, and now there's all different kinds of. There's actually a VPU nowadays, a visual processing unit. If you have a new MacBook Pro, it's all integrated in, where you have these different specifically processing unit for inferencing or for processing machine learning. Sometimes you would deploy it as FPGA or ASIC. What I'm trying to get at is there's a specific processing unit related to that. And that's what ONNX does. ONNX is the bridge between your machine learning frameworks, and when you're ready to run it, you'll be able to run it on these different devices. So ONNX means Open Neural Network Exchange. Think about it as an open format for machine learning models, just like as think about it as PDF, right? PDF you can write it in a word processor, like let's say in Microsoft Word, to convert it to a PDF, and now you have different ways in how you can view that document. You can view it on your phone, you can view it all without installing Microsoft Word everywhere, right? So once it's converted to PDF, now you can view it in the browser, you can view it in pretty much a lot of different places on Kindle and those kind of things, right? ONNX, Open Neural Network Exchange, it is open source on GitHub. If you go to onnx.ai, that's a good place to start. GitHub.com/ONNX is where a good place to start learning more about ONNX. And every time I would log in to ONNX AI, then there's more and more partners that actually collaborated with this technology. It got started by Microsoft and Facebook, I don't know, maybe 4 years now. And then of course through time, all these different companies have already started integrating ONNX in their platform. On GitHub, it's about 11,500 GitHub stars, 2,000 pull requests. You have about 200 contributors. There's 2,000 GitHub forks, and it's a graduate of Linux Foundation AI. And there's about 40 plus Model Zoo, and I'll talk about what Model Zoo is in different places where you can get all these different models. So now I did talk about ONNX, what it means. I'm going to talk about next is when should you use ONNX. And then today our agenda will talk more about how to create an ONNX model and how you would integrate or deploy it to deploy an ONNX model. All right, so when should you use ONNX? When you have something that is typically trained in Python, and you want to deploy it and integrate it with your C# application or a Java application or JavaScript, or the vice versa. If you have something that you trained using ML.NET and you want to use it in Python, you can. When you have something that's high inferencing latency, when you require something really fast for production use, it might make sense to use ONNX model. When your model has to run on an IoT edge devices, I have one here. It's called Azure Percept, and this Azure Percept is an Internet of Things device. I can run ONNX on that device. When you run a model, when you need your model to run on different OS or hardware. So let's say you did program it in Windows, or you did program it in Linux, or now you want to run it on Windows. ONNX is a bridge in order to do that. If you want to integrate it to your old Windows Forms application, you can be using ONNX. You can also combine running models created from different frameworks. So let's say you have a big company and you have data scientists, and these data scientists use a different framework. Let's say they use PyTorch, and then one of the teams also use TensorFlow. And one way to be able to combine these models together in one platform, in one framework, then you might make sense to be able to use ONNX and convert it to ONNX. Sometimes when training takes too long and you want to run, a transformer model on the device itself, let's say, let's say on a, that's when we start talking about transformer models where you have local training to improve your model. So now we'll move into how to create. The step one is to create an ONNX model. And then next time then we'll talk about step two, which is to deploy your model. So we'll focus first on how to create your ONNX model. So last year, during pandemic, when pandemic first started, my wife and I, we wanted to learn how to bake a bread. And, our first try was not really good. It was, it didn't turn out well. And we didn't know what's going on. And more we research because we want to improve our process. We really want to make a bread. And we found out that we were using uh, uh, cold water instead of warm water when we put the yeast together. And I was like, and I was thinking about this and understanding what came out there is that data scientist in your organization actually finds out the correct recipe or the secret recipe for your company. So they try different ways and how to improve. Like in this case, we're trying to to create a bread, and it didn't come out good, and we wanted to improve it, and so we found out different ways and how you would make the bread happen, right? So your data scientist and your team actually finds that secret recipe to make sure that that your machine learning model works out good. So they try out different parameters and how you would improve the training. So there's 4 ways on how you would get an ONNX model. One way is to get to the ONNX model zoo, meaning it's and then which is a website where you can download existing models. Azure Custom Vision Service, and I'll talk more later about that. You can also convert existing models, when it's written from a different framework. And then you can also use to train models using Azure Machine Learning or using automated machine learning. All right, first is ONNX Model Zoo. It's actually on GitHub with that link. There's existing, like in this case, image classification models that were, trained, with lots of different sample images and then published publicly that you can use. It got converted to an ONNX model, and once you got converted to an ONNX model, you can download it and integrate it to your application. So like these one, if you're talking about ResNet or SqueezeNet, or those things, you can actually download them, and it also gives you the size. So that's one way you find an existing model that you can just use and integrate it. Another one is through Custom Vision in Azure, where you can upload images and tag them. Like in this case, I uploaded different types of fruit, and I tag them. Hey, all these images are fruit, and then I can train and generate a model, and then I can just download them, and I can export them as an ONNX model. Okay, you can also convert from different models, convert from different frameworks. Like in this case, if I have something that is written in PyTorch, I can convert it to ONNX. There is different, all these different framework out there, machine learning frameworks that you can do. I'll show you a little bit of example here and how you would do this, but there are 3 steps involved in doing this, right? Load an existing model, convert to ONNX, and then save to an ONNX model. So let's look at it real quick. ONNX model, there's actually a way you can visualize it. If you go to netron.app, or it is actually open source on GitHub, you can upload an existing ONNX model, and it actually visualizes all the steps or all the functions that is actually running. So it's one way for a developer to kind of know what is the input of an ONNX model and an output of an ONNX model. Let me, since we have time, let's do a quick demo on that. We can do metron.app. Let me try to load that application. So you can open a model. Let's see if I can get one for you in their presentation. So I have one over here, which is this model. I can open it, and it kind of gives me, if I click on this, it gives me the properties, and it tells me the input and output of this small application, or this model right here. All right, so we'll move forward on that. So converting a model from PyTorch. So you would typically import torch.onnx and then load, like in this case, a PyTorch model. You figure out the sample input. In this case, it's 1 by 3 channels and 224 by 224 pixel of that image, and then you export it. So using torch.onnx.export, you pass in the model, the sample input, and it'll give you the ONNX model. Another way is through Keras. It's the simplest one I can find, where you load the Keras model using this Keras.model, and then convert it to ONNX and save it using the ONNX ML tools. Another way is through TensorFlow. There's actually a command line that you can use. Like in this case, there's tf2 onnx.convert to specify the TensorFlow model, and then it will spit out model.onnx. Scikit-learn, you can do the same. It's pretty much about the same, right? There's that pattern. In this case, I'm doing a simple training, where you're loading iris, and then once you train, you call fit, and then once it's loaded in memory, you can actually convert it, to ONNX using this. So what I'm trying to get at is, you have different frameworks where you can if a data scientist in your team, or you're able to train it into a specific framework, then you can convert it to ONNX and then start using it. You can also use ONNX as intermediary format. Intermediary meaning you can, if you want to use it on Android and it was written in TensorFlow, or it was written in PyTorch in this case, so I can convert my PyTorch model to ONNX, and then convert ONNX to TensorFlow. So that's one way that you can use it for Android. If you want to use it for iOS, you can use ONNX to convert it to Core ML. So there's also a way you can do that. You can use ONNX as a fine-tuning, meaning you'll be able to use it to be able to train another model. So you have an ONNX base model and create another ONNX model as you do fine-tune or do, like in this case, using MXNet or Gluon. So there's a lot of tutorials out there as a reference if you want to start working and doing that conversion. You can also use Azure Machine Learning to train your models. The idea here is, you can use it locally, and then if you want to expand it in the cloud, you can use the GPU clusters in the cloud to be able to do that. Automated machine learning and that does hyperparameter tuning. You can you can use automated machine learning to create a model and then convert it to ONNX using that one. At the end of the day, what I'm trying to get at here is you can do experiments, train and test in the cloud, but have a place where you can register and manage the model. And this way you can start versioning them. And once you start versioning them, think about how you would do, how you would do to manage your container images, right? Your Docker container images the same way. You want to might as well manage your models too and have a place where you can register them and then have different versions of it and then combine them together and deploy a service in the cloud. So that's one way you can start using ONNX to standardize in building your images. All right, so we did talk a little bit about how you would create an image model, right? How you would create an ONNX model. And now we'll start on the next step is how you would deploy them. So what's the difference between a baker versus starting a bakery? Totally different skill set, right? Last year, like I told you, we were trying to bake a cake and trying to be a baker or bake a bread or trying to be a baker. But starting a bakery is a totally different mindset and they're totally different skill set in order to start a bakery. So I come from a software engineering background. I'm not a data scientist. I know, and I'm kind of thinking like I want to learn more about machine learning. I want to learn more about what this data science is, and I figured how I would be able to incorporate this machine. I figured that based from my skill set and what I can do, I figured I can be more useful in this starting a bakery rather than being a baker. Meaning, I can take the models that a data scientist generates. It's not useful until I integrate it to an existing application or until it's being used or being deployed, right? So if you think about it, like in a bakery, when you start a bakery, you got to start thinking about where you put the register, right? How do you collect money? Or how do you make sure the flow of the whole process of creating that cake or creating that bread flows through, right? I mean, the layout of the store, the layout of how the whole pipeline would flow through. So as software engineers, I think that's the skill set we bring to this ecosystem is to be able to use existing models, right? Models or existing recipe, secret recipe from our data scientist and using it in production and productionizing it. So when we create these, these models, right? After it gets created, we can actually do the deployment. We can deploy it through Azure using Azure Machine Learning. You can do it as a VM. We can integrate it to our Windows or Linux devices or IoT edge devices. You can integrate it on the phone as a phone app. There's different ways how you would start using these ONNX models. And of course, every time you think about deployment, are you going to deploy it in the cloud or at the edge? And I'll talk more about what's the difference between a cloud or the edge. It's kind of like the same way as when someone, McDonald's versus Subway, right? McDonald's, where do they bake the bread for their hamburgers? It's baked somewhere outside the store, right? It's maybe in a warehouse somewhere or a big kitchen somewhere, right? And creates the bread and gets delivered to the store. So it's kind of like the same way as cloud versus edge. In Subway method, they bake the cake at the store itself. So the way I kind of see it, that it's kind of like baking it at the edge or do your data processing at the edge. So you always have to kind of think about where you would want to integrate that. And edge means how close it is to your customers or how close it is to your users. So deploying at the cloud, right? You can deploy it using Azure Machine Learning, where you would create a web service or an app, through AKS or a container instance. You can capture telemetry that way, make it as a service. That's one way, right? So this is that part right here on this side where you have your registration of your model, and then you build the images and deploy it and monitor as a service. You can also deploy ONNX in a Docker image, right? There's Docker images out there, or you can have these different ecosystem where you can use it as a starting point. You can also use ONNX. Actually, if you want to do conversion, you can do this Jupyter notebook environment. There's a Docker image that you can just spin out without even installing something locally in your machine, and you can actually do the conversion right there. So it's just a model that you can just it's a Docker image. What I'm saying is it's Docker image you can download and then be able to use it to convert. So that is one way. If you want to just without installing locally in your machine, you can just do a Docker image and do your conversion right then there. So what is the edge? Just a little bit. So you have your data centers. We're in the cloud, like for example in Azure. You think about it when you're deploying a service out there. It could be thousands of devices or thousands of machines. You can also deploy the fog level. If you think about 5G and all that, where it is in between the cloud at the edge, you can do deployment there. You can deploy it at the edge, meaning you can deploy it on the phone or the watch or somewhere closer to the user, right? It could be a gateway at the site that you can start doing this. And now when you're deploying, you got to start thinking about millions and billions of devices. It's more devices compared to what you have in the cloud. So that's a consideration whenever you do deployment at the edge. So right here where we're talking about constraint edge devices, there's different where you can have your ONNX model deployed on a microcontroller based. You can actually deploy them also using a smart edge device, or on-prem data edge. So this is closer to the user as compared to the centralized data centers, right? So why would you do that? Because of low latency, right? So if let's say you're processing images or videos, it might make sense to do your machine learning or AI at the edge because you need performance, right? At the end of the day, you want to make sure that instead of uploading each frame to the cloud, you run your inferencing locally at the device level itself. Scalability, it costs less because you're not uploading images somewhere and do the processing where you get charged per the ingress or however per call. If it's if you think about it, if it's a serverless application, you upload the images and send it to this application, a serverless application, you get charged by the request. In this case, if you're running it at the edge, it's scalable because you have the machine running locally doing that processing. Flexibility too. So let's say if you're flying, right, or you're a airplane, there's not enough connectivity or the internet is slow, you can still process it locally from there. There are some areas there that you can't ship out data outside of the certain location, right? That you want to process it locally or at that local site. That allows you to be flexible. So there's there's different ways why you would want to do deployment of your AI at the edge. And so because of that, there's a project called ONNX Runtime. ONNX Runtime, it is a high performance inference engine. So it's specifically for inferencing for ONNX models. It's actually started by Microsoft. It's under MIT license. It's not just limited to neural networks. It's also supports ONNX full ML spec, meaning it's even the traditional machine learning models you can use to do inferencing. It has extensible architecture for hardware accelerators. It ships with, of course, Windows 11, not just Windows 10, so you can use Windows ML. The best place to start working with it is, if you want to learn more, is onnxruntime.ai. ONNX Runtime AI, when you go there, you can actually, let's say you're working on Linux and you want to create a C# application, and the architecture is x64, and you want to do hardware acceleration. So it gives you instructions. It gives you instructions right here how to get started, what NuGet packages you would need to do, and some reference documentation. So this site allows you to kind of drill through the different ways and how you can use ONNX Runtime. So like I was telling you about the hardware acceleration, like different places where you can actually run that application and different architecture. So if you want your model to run on an ARM64 device and you're using, let's say Python, there's instructions on how you would do that and integrate the ONNX runtime. There's also ONNX Runtime Web, which is a JavaScript library running ONNX models on the browser. So you can actually ship the ONNX model, run it locally on the browser, or in this case, if you want Node. It actually uses WebAssembly and WebGL technologies to do your inferencing. It's optimized for CPU and GPUs. So it is available right there. It's not just limited to Windows 10 or Windows 11. It runs on Chrome, Edge, Safari, Electron, Node.js. So even on Mac, on Safari, you can use it uses WASM and WebAssembly at the backend and WebGL. Also, you can ship it on an iOS device using the browser and using Android also. So that's one way you can create an application that uses ONNX without converting it to a native application on the iOS or Android. On Windows, there's a Windows AI platform where you have WinML APIs that actually runs on top of the ONNX runtime. So let's say you have a Windows Forms application. This is one way you can use ONNX runtime to do that. WinML, you can, it's just an API that you can use for machine learning inferencing on Windows. Of course, if you want real-time and high control APIs, there's DirectML that's actually sitting on top of ONNX runtime. So this one is specifically for games, but notice that ONNX runtime specifically know if you're running CPU or a different, GPU or visual processing unit, or so it's what it does is it abstract that compute driver model for us if we just use the ONNX runtime. So if you're interested in, I'm going to do a demo next, and if you're interested in getting the code for my demo, that is the link, bit.ly/ml-onnx, and I'll post this again later at the end of the presentation, and we'll do the demo.
If you also want to post it in the Discord chat, that would be great too.
Yes, I will post it on Discord chat next. Good call. Okay, so let's go through here. I have these. So what I have here is a Python notebook. I have installed .NET Interactive in interactive notebooks into the Visual Studio Code in order to have Python notebooks. And also there is notebooks. Is it Python? Python notebooks. Notebooks here. Jupyter notebooks. That's what I wanted. So you can actually search for Jupyter right here. That it will give you support for Jupyter notebooks. So in this case, once you have that extension enabled, it would allow you to be able, in this case, I have this Python notebook that has .NET Interactive as my kernel, meaning it can run C#, or in this case, yeah, C# on this Jupyter notebook. So let's try to run this. In this case, these are all the NuGet packages that I would need for this application. I have Microsoft.ml, Microsoft.data.analysis, and then the ONNX converter and transformer. Our goal here is to be able to convert a model that was generated using ML.NET, and I will convert it to ONNX, and then use Python in order to do the inferencing side. So I have my NuGet packages. I would install it. Let's start that. And what this one does, it actually downloads and installs these packages. And then I would use this system.io and Plotly as part of my unit. And on this one right here, this one just makes it easier to read this CSV file as my training data. So let me show you what the CSV file looks like in this case. So this is just a simplified input and output, right? So if I put years of experience, I would like to guess the salary, that kind of thing. So it's just the minimal bare bones machine learning model that I can generate, right? So number of years, and then it'll give me a value, number of years, and to give me the value. So this is my training data. So I would load this as a CSV file using data frame. So let's see if I can run that one, and then display that data. So data frames is a way for me to, in ML.NET, to be able to use it for to kind of give me, like in this case, a description. So it gives me the min, the max, the length, and how much data do I have. And in this case, I want to randomize my data. Randomize meaning, in this case, I want to split the data, randomize and split it into training data and versus the test data, and create new data frames based from that. So once I have my training data and my test data, I can use ML.NET in order to do simple training, right? In this case, I have to use this Microsoft.ml. Everything in ML.NET, you have to use this ML context. And this ML context, in this case, what I want to do is to pass in years of experience as my input, and then create a regression and pass in as my output as salary, and create a pipeline based from that. So once I have a pipeline, there's always that pattern. There's always fit and transform. Fit allows me to create the model, and transform allows me to evaluate my model. So in this case, I'm training based from my those two columns, or those columns that I have in my pipeline. And now that I have a model, I would evaluate it. So you run model.transform, pass your testing data, and it will give you kind of like a metrics right here, and will display the metrics. Gives me some information about that metrics. My point here is I just want to create a model, right? And once I have the model, I can convert it to ONNX. Like in this case, I want to use the model that was generated by ml.net. I pass in the stream, which is the name of that ONNX model. And this data right here is just the sample data to pass in. Let's see if I can show you what data looks like. Let's see. See, that's my sample data. So it's using it to kind of know what's the input and output. And once the ONNX model gets generated, I can open it in Netron, and it would look something like this. So we know that this is the input, and data flows from here towards here. And what I'm really interested in is just the years of experience and then the score output, right? So whatever it guessed it needs to be, right? So in this case, if I put 1 year and it would come out with a number. In this case, since I've noticed that the input goes from here and also the salary, even though it's not going to be used, it's just a pass through in this case, right? But I still need it as part of my input. So I need to pass in years of experience. I need to specify some value there and then salary. And then it will provide this output right here. So this Netron allows me to kind of know what I need for input as a software engineer, knows what's my input and what's my output and what's important for me to read. In this case, that's my input, what type of data that I would need in order to run it, and what is my output, and what type of data I need to run it with. So now that I have the ONNX model, it gets generated here, right there. And that, of course, this is a binary file, kind of like a PDF at this point. So what we're going to do is we're going to use this ONNX model, and we are going to use it in another Python notebook. In this case, it could be any application. The reason why I'm using Python notebook is because I want to run through code line by line and show you what's happening. So in this case, I want to run this in this ONNX runtime. I would want to do a pip install. Now I'm running it in a Python. This is a Jupyter notebook, but its kernel, its backend is Python. So I'm writing a Python code. So I did a pip install, meaning that's the library I'm going to use. And in this case, I'm going to also use this ONNX runtime and this NumPy model, right? And then I would load this model ONNX into this ONNX runtime using this inference session. And once I have that, now that I have a session, I can start reading from that session. What are the inputs, the output? So in this case, input means years of experience. So it's, input is an array, right? So in this case, the years of experience, it tells me the shape, whatever I need to pass it in. In this case, also, I need to be able to, have another input, and then the salary is one of the inputs too. And I can also read the output. In this case, I'm only interested in score.output because that's the result of that application. So I've noticed that's the fourth item on the list, or the fifth item on the list. So if you go to here, it's actually 1, 2, 3, 4, fifth item on the list, and I'm only interested on that. The rest of them, I'm not really interested because it's just a pass through, right? Data set. So I'm only interested in the score that output. So I need to pass two things in order to run or to get output. I need to pass in years So in this case, I'm passing 2.5 years. I will have to put them in an array because that's what the requirements are. Another one is salary. In this case, it's negligible. Whatever salary I put there, it's not going to be used. So I passed this in as my input, and then I would pass it to session.run, and it would give me the result. So in this case, if I put 2.5 years, it will give me this number right here, which is part of the output. In order to grab that one, notice it's an array of array. And so that's how I would grab this number. So now I have output of my inferencing result. So what just happened? What we did was to create an ONNX model using ML.NET, using C#, and then I start using that ONNX model using a different language that is written in and also use ONNX runtime to do its inferencing and to get the results of the value that's passed in. Also, so I think that's cool, right? So you're not limited to just one language. You're not limited if it's written in PyTorch or ML.NET. However framework it was written in, you don't have to reuse it once you start integrating it to your application. So also on here, I have a sample of how you would do this in JavaScript, right? So if you want to use it in Node, there's a way you can read the data once you have the ONNX model, how you would read it and how you would have output using JavaScript. I do not have a lot of time to talk about the JavaScript side. I will go back to the presentation. So we have time for questions. Okay, so this is how it feels like after learning all the capabilities of what ONNX does. And I'm amazed in how you can as a software engineer, how you can actually start integrating ONNX to your applications and how easy it is if you have a model that was written on different languages or different frameworks, having a way to convert it to ONNX and based from that, start using it to your application. So in summary, what is ONNX? It's an open standard that you can use the right tools for their job and be confident that it would run efficiently on your target platform. So especially if you have an existing application out there and you want to include machine learning to it, ONNX allows you to be able to do that. How you would create ONNX models, we found out 4 ways in how you would do it. You can be created using framework. You can download using the model zoo if it already exists. You can use custom vision to generate a new one if you want to do a vision application. You can also deploy. How to deploy an ONNX model? You can deploy it using Windows ML, .NET, JavaScript, or Python. And that's what we have on our demo. You can use ONNX runtime, high performance ONNX runtime in order to integrate it to your application. All right. So if you're interested in learning more about me, my name is Ron Dagdag. I'm a lead software engineer at Spacee. I'm a 5th-year Microsoft MVP awardee. Personal projects at ron@dagdag.net, www.dagdag.net. Twitter, the best place to contact me is really through Twitter or LinkedIn, and it's linked out there. And I appreciate you geeking out with me about ONNX and learning about baking bread and the cloud and at the edge. I appreciate your time.
Thanks again to Ron.
All right, thank you. Have a good day.